Magandang gabi sa inyong lahat. This is Load Tests as Code, an introduction to K6, and I'm Nicole Mendoza van der Hoeven. I'm going to be sharing these slides at the end, so just sit back and listen and think of questions you want to ask me later because I really like answering questions. I'm going to talk to you a bit about the concept of load tests as code, why I think it's a superior approach in many cases, and then I'll do a demo of a load testing tool called K6 in particular. So just a little bit about me. I am a developer advocate at k6.io, and you'll hear more about that later. I've been in testing and especially performance testing for about 10 years now. What I love most about testing is the amount of choices that we have. It's a good thing too because I really like choices. I love traveling and I love languages. You're probably wondering what this has to do with load testing at all. Well, see, I think that people think about languages in the same way that they think about testing tools, that there's no point learning them if they don't become experts. Here are some languages that I've learned at one point or another to different degrees. Some of them I can still hold a conversation in, but honestly, most of them I've forgotten. And I'm okay with that. I learned each of them for a specific purpose, and if they served that purpose, I think that's time well spent. I think we should think about tools this way too. I think we should always be aware of what else is out there on the market. Even if we don't become experts in them, we should still be trying them out because that's the only way we'll be sure that the tools that we're using are the ones that are right for the job. Here are the testing tools that I've used. These aren't even all primarily load testing tools, but they are tools that I've used for load testing to varying degrees. Some of them I've honestly only downloaded and run some dummy tests on, and many of them I've actually used in actual load testing projects. I want to go through all of this because I'm going to be telling you about one tool out of these, K6. But I want to be clear that I'm not saying that it's the best tool for the job. I don't believe there is a best tool. And I think that anybody who tries to tell you there is one is probably just looking to sell it to you. And by the way, K6 is open source and completely free. Full disclosure, there is a SaaS version, but that just lets you run K6 tests on our cloud. If you don't need to use our infrastructure or results visualization, then you don't need to pay. The paid service and the free tool both use the same version of K6, and we're pretty committed to feature parity between the two because we believe strongly that open source is really the key to innovation. So to go back to this, I think that the best approach is to look at all of these apps as tools in your tester's toolbox. If you know what each tool's good at, then you can choose the right one for the job. And this presentation is about what K6 is good at. But first, let's look at all those tools again, but this time arranged by age. I've arranged this by order of when the tool was first released. So the left column is the oldest, and it has tools that are 16 years old or older. After that, each column to the right is in 5-year increments. And then in each column, I've also sorted tools with the oldest on top and the youngest at the bottom. So LoadRunner, for example, was released 28 years ago now in 1993. And JMeter was released in 1998, so it's 23 years old now. By the way, I should say that I'm not including load testing platforms in this, such as BlazeMeter or Tricentis Flood, because those platforms are still just using these same load testing tools under the hood. And if we look at the history of the tool landscape here, we might notice something interesting. The traditional way of writing test scripts involves some sort of GUI-driven tool. The tools that I've marked with a red box here are those that are predominantly GUI-driven. Now, this doesn't mean that they can't take code. LoadRunner scripts, for instance, use C, but it's still C within VueGen. So these tools are ones where there's an interface that needs to be loaded before you can write a load testing script. And what we see here is that load testing tools as a whole are moving away from GUI-driven testing. All the other tools, the newer tools that aren't in red, including K6, are using load tests as code. But why? Well, for starters, it can take significantly longer to set up and get started on a GUI-driven tool than a code-driven one. So let's take one of my favorite tools, and probably the one I'm still most familiar with, which is JMeter. To actually use JMeter, you need to first install Java separately, and then you install JMeter. And then most JMeter testers will probably tell you that there's a set of plugins that they always use JMeter with, because otherwise there's actually a lot of useful elements that you won't get. So to do that, you have to first install the plugin manager and then install the plugins. It might not seem like a lot, but it is a lot for a beginner that's just wanting to dip their toes in the JMeter water, so to speak. In comparison, here's a GIF of how to install K6 on the terminal in real time. It takes 7 seconds. It's done now, and then this one just repeats. So you can actually install a tool faster if you don't have to worry about a UI. It can also be difficult to collaborate on a UI script. K6 scripts are written in JavaScript, and that's an intentional choice. I've found that it's great for getting developers to contribute to tests, especially if they're already writing in JavaScript. They can write unit tests for performance with K6 just by importing it as a library. See, if we shift left, unit tests are already written as code. And if we shift right, CI pipelines and now even infrastructure are written in code. So why should testing be in the middle, isolated, insisting on a GUI when we could actually be bridging the gap between the two and bringing everyone into testing to some degree? This JMeter error might be very familiar to you if you've ever been on a team with multiple people working on the same script. So this just means that you've tried to load a script that uses plugins you don't have installed. When you work on JMeter, everyone needs to have the same version of Java, JMeter, and the same plugins. And inevitably, at least in my experience, there's someone who forgets to tell everybody else that they've installed a new plugin and they're using it. So you might be wondering why I'm picking on JMeter, because JMeter scripts can be saved in a JMX file in XML format, so that's still code, right? Well, so let's have a look at that. I scripted a very simple test in JMeter. It makes one GET request, names that transaction 01 underscore home, checks that a certain string is found in the response to make sure that we've hit the right page, and then it does a variable think time. This is just a one user, one iteration script. And this is what it looks like. This is the full JMX file, and it is 73 lines of code. So if your teammate checks this into your repo and you need to modify it to add your changes, it's going to be quite a pain to do that just from here. So let's look, for example, at how we would go about changing an assertion. So this is the assertion here. What this part is doing is it's looking for this string of text on the page that we get to make sure that we've gotten the right one. Now, if you wanted to change this, so let's say you don't want a response assertion, let's say that you want to check for the status code instead, or you just want to check, you just want to add another assertion like this. What would you actually have to do? You might think that you just have to copy this line, but if you look more closely, this entire block is actually just one element. So this is the problem with XML, right? Because you'd have to duplicate this entire thing. And on top of that, JMeter has some quirks to the format. So for instance, what does it mean that the test type is 16? Or what is the string prop name? Would you have to change that to something else if you were just going to create another response assertion? It's not entirely clear. So if it wasn't you that wrote this script, and maybe even if it was you, it could be a little daunting to understand it and then to also modify it. In reality, you're probably not going to even try to script in XML. You're most likely going to just download the script, save it locally, and then open it up in your JMeter installation. So that's why I consider JMeter mainly a GUI-driven tool, because it's not easy to script with in code. So to compare, this is the same test in its entirety on using K6, and it's 11 lines of code. This is literally all you need after running that brew install K6 command that I showed you earlier. So there's no setup between running that command on the terminal and just copying this script. This is way easier to understand and to modify. You can see that the text verification is actually just one line here. So if you wanted to create another one, copy this line, maybe change the name of it, and then change the actual string that you're searching for, and that's it. It's fairly simply laid out, so you could even make this change on GitHub or something if you needed to. The other thing about GUI-driven tools is that they require very specific knowledge that isn't transferable. A GUI can seem easy, but that's actually misleading. Every UI you learn is for that tool only. That's why adherence to design standards is so important. It's a way to try to make some of that UI transferable, but even then, learning a UI is mostly not a transferable skill. Learning the LoadRunner UI, for instance, won't help you with JMeter at all because they have completely different menus and they even have different terminology. A virtual user in LoadRunner is a thread in JMeter. So a lot of these things won't be transferable. As testers, that's a problem because we know that tools come and go. When we do have a choice, sometimes we don't, but when we do, it makes sense to me to choose to learn something that we can use even if and when a tool is deprecated. If you learn a programming language that's useful in other contexts, then it won't be wasted when one of the tools that you're using it for goes away. So now for execution. There's actually no way around it. Having to render an interface is going to cost. It's going to make that tool take up significantly more CPU and memory when you're executing it. Here's a graph comparing the maximum throughput requests per second and the memory usage of many open source load testing tools. This is on the K6 blog, but the source code, all the test scripts, and all the details are on the blog for you to try yourself so you can confirm these results. Now, the blue bar shows how many requests per second each tool can generate on a single load generator. And then the orange bar is the memory utilization for the same test. So a big blue bar and a small orange bar is good. You'll see that in this group, the only GUI-driven tool, which is JMeter here, has the highest memory usage and a middling maximum requests per second. So why does memory utilization matter on a load generator? Well, it's always a good idea to monitor the resources on your load generator to make sure that it's still healthy. Otherwise, your tool could actually be the bottleneck. You're relying on something slow to measure your application. So if you get bad results, how will you know if it's your application or your tool or both? And by the way, I want to point out that the next most memory hungry tool here is Gatling, which is also a Java-based tool, even though it's code-driven. It turns out that some of the innovations of Java 30 years ago, because it was created in 1991, can also be hurdles in using it for performance testing today. For example, I think it's at this point a rite of passage among JMeter load testers in seeing this message. This means that even though the load generator might still have enough memory, Not enough has been assigned to the JVM that JMeter runs on. This means that you're not only having to monitor the resource utilization of the load generator, but then also the JVM on top of that. So that's an added layer of complexity that you have to tune that you might not really want. This is from the official JMeter documentation. And they even tell you that before you start your very first load test with JMeter, you should increase the Java heap size. And also note this warning here, don't run load test using GUI mode. So even they agree that using a GUI during a load test is not the best idea. The reason that this matters is that the most expensive part of running a load test is not the tool itself, because there are open source tools for that. It's actually the load generation that is more expensive. Regardless of the tool that you're using, you're going to need to pay for the machine to run the load from, whether that's by provisioning your own on-premise load generators, by paying a cloud service like AWS, or by paying for a full tool package where they have the cost of the machines built in. How resource hungry a tool is or how much CPU or memory it utilizes affects how many users you can run from it. Let's say you need to run a test with 10,000 users, right? On one end of the tool landscape, you might have tool A that runs 5 users per load generator. This might sound extreme, but that's actually probably what you'll get with something like Tosca. You'd need 2,000 load generators for that amount of load. On the other end of the spectrum, test using a tool like, say, tool B, like K6, you can run all 10,000 with a single load generator. 2000x is an extreme case, right? But even a 10x increase in cost isn't something that most of us can take lightly. So what we have to think about is that GUI worth that? Now for continuous testing. GUI-driven tests also make it hard to include load testing in CI pipelines. In continuous testing, we want to make it so the testing is automated and tied to development, so that any new code is tested for not just functional defects, but non-functional and performance defects as well, and all this in an automated way. The difficulty of version controlling GUI-driven tools also means that they're harder to automate and tie into a commit or a release. Many tools don't integrate well with CI tools like Jenkins, Circle CI, or Travis CI because they might not even be able to be run in a CLI. It can also be difficult to troubleshoot a CI run test if you have to open up an application to view the script properly. So it can be hard to hook up to CI/CD pipelines. The other problem is that not being able to automate a performance test in a pipeline means favoring huge, several thousand user tests that are manually triggered. These types of tests are expensive and require a test environment. But that's like saying there's no point running a single functional test case unless you can run the entire test suite. The big load tests are really flashy, but not enough is said about the importance of smaller tests. Not even necessarily load tests, but just maybe tens of users instead of thousands, but that run regularly throughout the day as you release to production. You don't need an environment because it's just 10 users. You don't need special preparations, and you still get a good idea of the performance of your application if you run it consistently. But this only happens if you can tie your performance tests to a CI/CD pipeline. Now, the alternative to all of this is keeping load tests as code. K6 is not the only tool that lets you write tests as code, but here are some of the features it has that make it one of the best examples. And then I'm going to jump into a demo. K6 is written in Go, which has huge performance benefits as a programming language at a fundamental level over something like Java. Instead of scripting in Go, though, JavaScript is what you'll actually be scripting in with K6. And we chose that because it's nearly ubiquitous for web apps, as well as some test tools that you might already be familiar with. Now we have recorders and converters that let you create a K6 script faster, including just being able to download a Chrome or Firefox browser extension, hit record, navigate to your website, and generate a K6 script from that. If you just want to write a script in JS from scratch, we have IDE extensions that help with that. You can also pipe your results out to a variety of visualization and APM tools, as well as CI/CD tools. And all of this that I've mentioned so far is available with a free open source version. Okay, now let's go into the demo. Let me just set this up here. Okay, so this presentation that I've actually been using might look like, your typical PowerPoint slides, but it's actually, I'm practicing something called presentation slides as code. So let me show you what it looks like. I've increased the font here. Let me know if someone can't see it. So this is actually my presentation. It is a markdown file, which is a markup language, if not a full programming language. But it is just written in text, and it's an alternative to PowerPoint. So this is exactly what I've been presenting off of. And if I change this, then my local copy of it will change as well. These slides then, so they're separated by these, are are published to my site. So it's a pretty basic app. That's actually what I am presenting on. So if you look here, this is the URL for the slides. Now, what if I wanted to load test this site? And I want to keep the load test just in within the code itself. So I will probably create something here in public. Let me create a new file, and I'll just call that slides test.js. So what do I actually put here? Now, first you need to have K6 installed, right? If you're going to go through this, but literally that's brew install K6 as I showed you in the GIF. So let's go over to the K6 documentation. K6.io is the site. Go to documentation and then go to running K6. And I'm just going to copy this very simple script here. And I'll paste that into my text editor. This is VS Code. But of course, this is not the site that I want to test. I want to test this site. So I just copy the URL of that. I'm just going to change this one here. And we want just like the base, the first page, for starters at least. Okay, so this is a very simple K6 script that now is going to hit the presentation basically. Let me open up the terminal here, and I'm going to type K6 run, and oops, I didn't actually save it. Save that, and then I'll type that. So this is our very first K6 run. Can look daunting because there's a lot of data here. And by the way, you can also change how all of this looks. I've just got it to the vanilla setting right now. We can see that there's one virtual user that was run here. There's one iteration, and the request duration was 177.3 milliseconds, which is great. Now, when you create a load test, one thing that I don't see people do a lot is create text verifications. And I really think that that's super important to include because an HTTP 404 is not always set properly when a site returns an error page. So you might actually be getting an error page, but because you're not getting that 404, it returns it as a 200, and you think, that your load test is hitting the right thing, but it's not. So the way that we can change that is by adding a check. So in addition to sleep here, I'm going to import check. I will put this in a variable. Oops, let response equals. And then I am going to try to create a check. So it's just check. And as I'm typing, you can see that this has some pretty helpful suggestions. In this case, this is exactly the format that we're wanting to do. But let me just type that out, response, because I'm using different variables as well. And I'm just going to do a text verification. And I'll say R equals, R body. And when we do body, we also can check which method we want to use. In this case, I'm going to use includes. So this is the advantage of having a programming language that also has IDE extensions. You can fill all of this in. If you don't know the exact syntax, you do have some help here. Now, so what are we going to put in here? I'm going to go over to the same slides and I'm going to go view page source because I want something that an error page wouldn't have. So I'll just use this an introduction to K6 heading, copy that, flip back here and paste that. Okay, so now that I've done that, I'm going to, hang on, just let me look at my notes here. I'm going to now run this. Well, I guess we'll have to put the punctuation here. I always forget that. Okay, I've saved that. I'm going to run. Okay, so it was the same sort of thing here. We see that the text verification has been added, so we know that that's right. Now, if at any point we wanted to look at the HTML itself or the response that was returned, we could do HTTP debug equals full, and that's just going to run the same test, but it will also add the exact body. So this is part of the JavaScript that the slides run on. So this is the actual presentation with all of my speaker notes. Okay, so that's done. Now, let's try it. So this, as of now, I'm just running it on my local machine. Everything up until this point has been just the open source version, but now I'm going to show you what it would look like in the SaaS version. So that's K6 Cloud. Instead of running K6 Run, so right, that was what I did before, I'm going to do K6 Cloud. And I've already authenticated with my cloud here. I won't show that because then you would know my API token, but it's also just a command. So K6 Cloud slides test JS, and I'm going to run that. So that's actually now running on the cloud. And you'll see the output here has a link. So let's follow that. Okay, that opens up my dashboard, my account on K6, because I'm already signed in. Now it is running just one VU here from Ashburn. So this is an AWS availability zone. And this is probably not going to be very useful because it's just one virtual user and just one iteration. So we're going to stop that so you can see the results coming in here live. And that's the HTTP request as well. You can add different sort of charts, and so you can monitor different things here. I'm going to close that and go back here. I'm going to stop this, and then let me actually add some more virtual users here so that we have like just a little bit more to see. So to do that, I'm going to export const options. And then I'm going to save the number of views as 10. And let's say that for the duration, we'll run it for 3 minutes, just so that maybe we can actually see it live finish during this presentation. Okay, I'm going to now save that. And now if we go back to the K6 Cloud app, oops, let me head back to that. So we should see this one here that we just ran March 16th. Yep, 11:05. So let's go back here. And you'll see that there are actually many different tests here. Now, the reason for that is that sometimes these are like manual, but what I've actually done is I've integrated it in with GitHub Actions. So let's go and I'll show you how to do that. Okay, so we have slides test.js here. Let me open up this here, cleared that. And this is actually a GitHub repository. So we'll see that we changed something in the slides here. So I'm going to do a git add, git commit. Oh, it's, yeah, so that was the JavaScript file, the test that we actually added. So I'm going to just do a commit. So I'm going to say walkthrough 2. And I'm going to push that. Now, this isn't something that's part of K6. I'm just deploying a very simple application to show you what that looks like. So to do that, let's go to GitHub. This is my personal GitHub account. And I've actually set up something in GitHub Actions as my CI pipeline so that when I push a commit to the repository, so this could be any code that your developers are working on, it does not only deploys that code to the site for public consumption, but it also runs a K6 test. So you'll see that there is a build step here for the test in particular. Now we are saying, I named it K6 load test because it can be used for that, but in my case, I'm actually just using the 10 users that we set previously. So if we click into that, oops, we can see that K6 is actually running now, or at least it's starting to. So let's head back over to this. And we can see this blue thing here that's flashing is the test that we've just kicked off. So that is running in real time. You can also see that there's a test running here. And if we click on that, we're going to be able to get real-time metrics from it. So let's take a step back here and let's see what we're doing here. What we've done is I have an application, and it is just a way to publish PowerPoint or presentation slides. But now I've tied it through GitHub Actions so that every time I make a change to my slides and push it publicly, a test is also triggered. That test is going to go to this page, load tests as code, and it's going to make sure that it's the right page that I'm getting. At the end of this, we're also going to have this link here for output. So if we weren't already watching it, we would have been able to click it and it would take us right to the results of the test. You can also set up notifications. So, if you have thresholds where if you have over 5% error rate or whatever you want to check for, then you can send a notification to Slack, for instance. I have a specific app here. This is a private Slack, and you can see that there's a message that just was sent from the run that we started. So that's just a good way to kind of communicate your load test to other people so that they can also watch it or fix any issues that you might have run into. Okay, so the reason that I went through all of this and I went through the whole thing with the PowerPoint slides as code or presentation slides as code is I wanted to drive home the benefits of having all of this written in code. Just in the same way that it would be difficult to think of using PowerPoint, which needs an interface to run and create these presentation slides. It would be difficult to think of PowerPoint being incorporated in some CI process that automatically fires off a job on a push or a change, it's also difficult to think of a GUI-driven tool being integrated into this sort of a workflow. Having everything as code really yields some advantages there for continuous testing. So let's head back to the presentation. Okay, now, I really love this sign because it's so representative, not just of our language, but of our culture. Filipino language, culture, politics, religion, and even education are all heavily affected by the fact that we've been colonized by several countries. And most modern Filipinos embrace those external influences, as evidenced by the fact that this is a sign in the Philippines, but most of the words on the sign are in English. It's not even even though it is an official language, it's not a native language for most of us. So, this Sapir-Whorf hypothesis is a linguistic hypothesis that postulates that languages shape the way that we think. They set boundaries for our world and inform our actions. This is partly why I love languages and I spend so much time studying languages, because it's completely different when you learn a language and speak to someone in their language. You have a completely different view of their culture. But I think the computer languages aren't much different, because languages that you choose matter and the tools that you choose matter. So let's talk about the Sapir-Whorf van der Hoeven hypothesis. It's a little too long. It changes the whole point is that the tools that we choose change the kind of culture that we want to have. Do we want to run load tests once every now and then, or do we want performance tests to be part of the development process? As testers, do we want to be solely responsible for quality, or do we want developers and DevOps engineers to all be contributing to some testing activities as well? And do we want a process that has manual steps, or do we want something that's mostly automated? Tools change the way that we test. We may be testers, but we're end users of the tools that we use. We should be testing our test tools and be more discerning adopters, because the tools that we do choose set the limits for our testing. That's why it's so important to try other tools. To paraphrase Abraham Maslow, if all you have is a hammer, then everything looks like a nail. That's it for my presentation. Thank you for listening, and I'm happy to take any questions now. Here are some links that might be useful. This is the K6 site and my personal site if you want to follow along with me. These are the Twitter accounts for me and for K6. You can find the slides here. This is just going to redirect you back to this site that I'm using right now. I also do a lot of videos on our YouTube channel, including a weekly live stream on everything related to K6. And you can also email me here. Thank you for listening.